Hello and welcome to another session in physics. In this session we'll be looking at the topic electric circuit. But before that, let us review the previous lesson. Welcome back. At this point, let's try to take the definition of the term electric circuit. But when we talk about electric circuit, we have to know the basic definitions of some things like conductors, semiconductors, and insulators, because these are components that are really important in the study of electric circuit. So when we talk about conductors, what exactly are we talking about? Though we've talked about them before, but let's refresh our memory on that. Conductors, put simply, are those materials which allow electrons or the passage of electrons through them easily. Examples of such materials are things like metals, graphite, acids, and salt solutions. These are materials that allow the passage of electrons through them easily. And we know full well that if this is a metallic conductor and this is point A and this other side is point B, and electrons are moving steadily from one point in the conductor to the other point, we say that electric current is flowing, which in turn constitutes electricity. The second material or terminology we need to come to terms with is semiconductors. So when we talk about semiconductors, what do we really mean? Semiconductors, put simply, are materials whose resistivity is midway between good conductors and insulators. Examples of semiconductors are elements such as germanium and silicon. Silicon predominantly are used for transplants, for those that go for plastic surgeries. And then finally, insulators. Well, insulators, put simply, are materials which do not even allow the passage of electrons through them. Examples of such materials are paper, plastic, glass, oil, cotton, dry hair, polythene. These materials are made up of molecules that are resistant to the passage of electrons. Hence, they are called insulators. Remember vividly that we said semiconductors have a resistivity value that is midway between that of good conductors and insulators, which means semiconductors under certain conditions can be good conductors and in other certain conditions they can be insulators or bad conductors. Now let's look at what we mean when we talk about an electric circuit. Put simply, an electric circuit is a complete path that has been provided for the flow of electric current. I'm going to show you the circuit diagram of a representative or symbolic representation of such a circuit, and we're going to analyze some of the components therein. Look at this circuit very well. You see the cell, you see the rheostat, you see the ammeter, you see the resistor, and you see the voltmeter. This is an example of a DC cell. Now these are the components, the electric components that make up this DC cell. So let's try to analyze them one after the other. Now let's start with the cells first of all. So what are these cells? Remember, in previous lessons we've said that cells are chemical devices. They are chemical devices which produce electric force. Chemical devices which produce electric force. They produce electric force, yes. And this electric force is responsible for pushing. It's responsible for pushing the current and making it to flow. And now the second one we want to talk about is the switch or the key. Even though it is not here, but sometimes its position is usually around this area. The switch or the key. I'm sure you're all familiar with what a switch is. For instance, the light is off and your mom or your dad asks you to go switch on the light or put the switch back on. Well, a switch, put simply, is a device that is responsible for starting or stopping the flow of electric current. A switch is a device that starts or stops the flow of an electric current. Yes, we have two types of switches that have functions in circuit. This one is when the switch is open. When the switch is open, there is basically nothing here. What it simply means when we say the switch is open is that the switch is off. So when the switch is open or off, current can no longer flow through that circuit, because you think of it as a bridge that has collapsed, and as a result, vehicles cannot pass through anymore. That is what happens when a switch is open. When a switch is open, current cannot pass through anymore. It's as if the bridge has been collapsed, the path has been tampered with. And then when a circuit is closed, this no longer exists. This no longer exists. This is a closed circuit. This diagram you're seeing right now is a closed circuit, which means in this circuit, currents can flow. Yes, the path is complete, and there is no reason why electrons should not get to the desired destination. Now, from the diagram here, you would have seen this. This is an ammeter. Of course, at this point, you should know already that an ammeter is an electronic device that is used for measuring current flowing in a circuit. It is used for measuring the flow of current in a circuit. Used for measuring flow of current in a circuit. And what about a voltmeter? Voltmeter, as the name implies, is used to measure voltage or potential difference. It is used to measure the potential difference across the terminal of a node. How about the rheostat? The one you see right here, the rheostat here. So rheostat is this? Yes, the rheostat is a device that varies with the flow of current. Rheostat is a device that varies with the flow of current. What do we mean when we say it varies with the flow of current? It varies with the flow of current in that it helps to either improve current flow or decrease current flow. It is used in devices such as radios, in tuning, or it can use to increase the volume or reduce the volume in a television set. Alright, at this point, let's talk about a resistor, which is the final component here. Look at the name, resistor. Resistor means to oppose. So therefore, in an electric circuit, the resistor is a component that limits or regulates the flow of current. It limits or regulates the flow of current. It limits or regulates the flow of current. That is what a resistor does. And all these components make up this simple AC circuit. At this point, let's talk about the definition of some physical quantities associated with an electric circuit. The first is electric current, which is symbolized by I. Electric current, put simply, is the measure of the rate of movement. When we say movement, we mean the flow of charged particles along an electrical conductor, that is a circuit. It is a simple electric charge that is in motion, consisting of moving electrons. As you can see from the diagram here, you'll see that this is a piece of wire consisting of negatively charged particles, otherwise known as electrons. And these electrons are in constant random motion from one point in the conductor to another point. When electrons are in motion, we call them electric current. And then there's this one that is all too important as well, potential difference. As we've already said in previous lessons, potential difference simply refers to the work that has been done in a circuit. The work that is done between 2 points in a circuit in taking a coulomb of one charge, or in other words, 1 coulomb of charge, and moving it from one point in that conductor to another point. So if there is a charge at this point here, the work that is being done in pushing this charge down to this spot is what we call potential difference. What about electromotive force, also known as EMF? The EMF of a cell, simply put, is the potential difference that has been created between the terminals of that cell when it is not delivering any current to the circuit. In other words, it's basically a short circuit and can be used to take the reading of the potential difference that exists in that particular cell. We also have the internal resistance of the cell. And what do we mean by the internal resistance of a cell? Internal resistance, represented by small letter r, is simply the resistance that has been offered by the electrolyte to the motion of the current. In previous lessons, we've learned that electrolytes are solutions that accommodate electrons, the anodes and the cathodes in them, and help to set up a sort of convectional current, where current flows from one terminal, one electrode, to the other electrode. What about this resistance? This one is external resistance, represented by capital letter R, and it is the ratio of the potential difference across the conductor to the current that is flowing through it, and it is measured in the ohms unit, as you can see from the slide here. Here is a diagram of what the resistor should look like. And that brings us to Ohm's law, having talked about potential difference, resistance, and electric current. Now, Ohm's law stated that the current that flows through a metallic conductor is directly proportional to the potential difference across its ends, provided that other factors such as temperature remain constant. And that gives us V, which is potential difference, directly proportional to I. Therefore, we have V equal to IR. At any point in time, you can make any of this the subject. For instance, let's say you're asked to find the current becomes V over R. And if you're asked to find R becomes V over I. So using any of these three, you can find potential difference, current, and resistance, respectively. As you can see from the diagram here, it tries to explain the relationship between potential difference, the current, the resistance, and the power of an electric circuit. Each of these things you see here are equations that can be used to prove the validity of Ohm's law. And we urge you to take a look at the notes that has been attached to this video. Thank you for joining us. This will appear on your screen.